This week we'll be talking about transformers and how they work in large language models. For the beginning, we have generative, which generates a piece of text. Then we have pre-trained, which is using little knobs. And then we have the transformer. So what we have here is three ways of what a transformer can use to do its next part of the system, which would be basically generating the next piece of wording. First, you could use text, obviously, which you could do fill in the blank after. You use pictures. You could always use sound bites. And the way how it would generate the next piece of text would be these types of tokens, which it would take, obviously, the first piece of the sentence. It would take little pieces of data, part of the sentence, to create the next piece of text. It could also break down images to multiple squares, which you gather information from each square. And also with soundbite, it'll take part of the soundbites, like basically like sending us text. Right here, we have what is inside of the transformer. The first part is the attention model, or the attention block, which basically has these vectors, which is I guess you could say each vector is a word, and it gets information from the words and something like context clues to generate the next piece of wording that should come after to it. The next step or the next process in the transformer would be the multi-layer perception block, which this one is basically like kind of like the attention model, but it gives more in depth of asking questions for each vector so it can get to the next word. Basically, for transformers, they keep doing the attention block, multi-layer perception block, attention block, multi-layer perception block, attention block, multi-layer perception block many times until it finishes its process. I mean, a way to think about transformers is basically like taking in an image or a word, and you have these uh tunable little dials that will gather information from whatever you have here. Then after that, change their little knobs, grabbing words, making it to fit that picture or word. A simpler way to think about it is like linear regression, where you have your XY axis, and then you have possibly like a million words that are yellowed out, but then you'll keep changing the tunable knobs into a line to where it will hit the right word. Right here we have the embedding matrix, which basically has a dictionary of words, basically, which is like the million words in the world, and gives them all a little vector column, which you could pinpoint on a graph like we showed in linear regression, which is basically like the same thing as linear regression here. To show how it's the same as linear regression, it's basically the same thing as you have to put a bunch of words on a graph, but in here we have a 3D vector graph because there's too many words out there in the world to fit on a 2D graph. And also with a 3D graph, you could pinpoint words on an up or down scale or a left or right scale. As you can see, we have the word tower here that we're looking for, but we could also find other words like in towers, as it would be down because it is multiple. Or you could find a lighthouse, which is almost the same thing as a tower, but it's somewhere else. It is going to a different direction. You can see gates. Gates could be part of a tower, which it would be in the same area, but it would be different because it's not what we're asking for. It could be a building, which is in the same kind of x-axis, but it's also not what we're looking for. This is in a different direction, which could be done with multiple different words, which makes it easier for to pinpoint words. Right here is the unembedding matrix, which basically makes it so that you can take a sentence like Harry Potter was a highly unusual boy. Least favorite teacher, professor was, as you can see, is a big word, is Snape. It would take this sentence and use the keyword Harry Potter because if you say a highly unusual boy and his least favorite teacher was Professor something, you would never get to the point of you would just pick a random name because you won't know a professor. But right here we have Harry Potter, which gives context to where it can find which professor Harry Potter didn't like. To summarize this week, we learned about the Transformer. which basically has an attention block, which could equivalent to embedding, to where it has a 3D vector graph, to where it would gather all the words into a graph depending on its X, Y axis and Z axis, and it will gather words in a group and pick out from it so it could get to the next word. Then after that, we have the multi-layer perception block, which is basically unembedding, which it would ask multiple questions, sort of like context clues to get to the next word. Also, thank you, Three Blue, One Brown, as I was able to use their video and take pictures from their video to do this week's video.